I'm Miriah.
I'm Chris.
And I'm Matt.
And welcome to Domesticating AI, our bi-weekly podcast of practical AI for developers. Hopefully by now you're starting to embrace the feral OpenAI landscape and tame it. I have coworkers telling me to keep your AI in a leash now. So whenever I make snarky comments about using AI at work, they're like, keep it AI on a leash. I'm like, somebody's paying attention. So today we kind of just want to talk about hosting your own AI. I have been getting a lot of hardware recommendation videos on YouTube. They're like, you have an AI podcast. Why don't you look at hosting this 5 Mac Mini cluster for your AI inference? And then there's a ton of like people who have Homelab groups with Sparks, and it's just, it feels like there's a high barrier to start with AI. And then you have, but we all have I don't know. We talk about, there's a barrier. Home labs are expensive, but like you don't need to start with a Spark, right? You can start with an old laptop or a Pi or whatever. Like what is realistic for home labbing or hosting an inference server or whatever with the stuff that you potentially just already have from work or whatever?
Yeah, I mean, this is how I got my home lab started. It was literally, I went and bought a Raspberry Pi because I thought it was cool. And then
they are cool.
And then I went and installed Pi-hole because I had no idea what else I wanted to do with it. And I hooked it up and kind of left it like that. And then later on, I attached an old gaming computer that had a GPU on it. And, I was just doing simple machine learning training and inference with it. It wasn't anything big. And that's kind of just how it lasted for a long time until probably around last year when I started really investing. One, I needed to get a new gaming computer. So then I put in then I had 2 gaming computers in my,
Yeah, okay.
and then I got the Spark as well, and so that's kind of how mine grew. It was just always kind of cannibalizing old hardware. I know, Chris, you've added your phones to your clusters.
Old phones.
That's something I haven't risked yet or started yet. But
Risked. Okay. Yeah. I started in 2019, and anybody who went to college and had a Pell Grant is gonna know this, where you're like, okay, they're giving me some FAFSA money for my tuition. I was fortunate enough to go to a school where it actually paid for my tuition, right, completely, but it wasn't enough to pay for my tuition and pay for a gaming computer so that I could do machine learning at home. And so there was one semester where I spent my FAFSA money on a gaming computer that had a 2080 GPU in it and had to pick up a whole bunch of extra shifts to pay my tuition. I felt like that was okay because it did pay for my tuition, and then it was just different order. Sorry for the mic. That was the beginning of my home lab and self-hosting experience, because I wanted to run these examples that I was seeing online from wonderful people like Andrew Ng and Jeremy Howard doing fast AI and the Coursera machine learning courses. I wanted to run them on my hardware instead of on Coursera's cloud or on Google Colab or any of that, right? Eventually I found out, eventually I hit a point where my 2080 GPU and 16 gigs of RAM couldn't run what I was trying to do anymore. And that was when I think GPT-3 came out. And it wasn't because GPT-3 was too big. It was because it was the first one that was API only, and that pissed me off. So I got into Raspberry Pis. I got into building my own PCs specifically for this, right? That's where I started, though.
Yeah.
You guys are nerds. I started with nothing. Actually, I had a Raspberry Pi that I put a model on, and I was like, this is too slow.
Oh, yeah. Perfect.
And then I got a refurbished Dell for $200, and I hosted Llama 3.1, a 7 billion model on it for 2 years. And that was it, right? And it's what can you do? It was a chatbot, but I don't know. I think had 32 gigabytes of RAM. It was about the same price as a Raspberry Pi. Like that's essentially, it was just like a refurb, whatever. I still have it in there. So I guess the question is, right? So you don't have to spring for the latest. What can you reasonably do? You were doing training, and Matt started doing training. I started with an inference. Like what
you can reasonably do both. Like I said, the 2080 and 16 gigs of RAM got me through training from when I bought it in early 2019 through like 2022, and I was just fine. I could train GPT-2 on it. I could do all sorts of. I could obviously inference GPT-2. I could do a lot of the classical machine learning stuff. Yeah, that gets you like most of the space. And honestly, like I haven't tested this, but I could probably finagle an LLM, maybe one of the smaller Quen models, to run on that pretty well even now. Right? The 2080 is where you're gonna have hangups that like it's not quite as fast of a GPU and it's a laptop GPU instead of a desktop GPU, but like you can still work with that. It's still an accelerator, you know?
Yeah.
Take a step back and think what do you want to do? Like for me, the majority aspect of my Homelab was for learning and for growing. And so that's why like an old gaming PC was perfect, because it was very limited hardware, like I needed to upgrade because it can no longer run the best games, and so I think it actually, like my first one, it had 12 gigabytes of RAM, which was not VRAM, right? Like this is RAM. I think it had 6 gigabytes of VRAM, so very, very limited, especially in today's hardware. But it was just like, that was good for me because it helped me learn to make the engineering trade-offs when it comes to inference and training. And like even back then, that was very limited because like it was very easy to have a data set bigger than 12 gigabytes. And so I was forced to learn how do you stream large amounts of data to train these models. This is the hardware I use to train my StarCraft bot that I presented at meetups on and things like that.
It is the best meetup talk ever.
And so it's just so for me, there was learning experience. So there is a benefit in kind of being hardware constrained. And like, if I ever needed to, I knew how to like go up onto Google Colab or to get, an EC2 instance. And now it's even easier and cheaper with things like RunPod and Modal to spin up something. And so, if your goal is to learn and that's why you want this Homelab, like it's almost a benefit to you to buy kind of more constrained hardware and then use the cloud for one-off tasks or things like that.
Well, I mean, look at all of the tech people that we kind of revere, right? From like Linus Torvalds to like some of the Atari devs, even, where like they are really good at knowing what their thing is. They know their niche very well because they went down to the lowest level and they built it from the lowest level using like terrible hardware from whenever they were. Like they weren't even developing on the best hardware of their times. You know what I mean?
Yeah, I mean, John Carmack is a really good example of that. Like the reason why he's a legend is because he was able to build, Doom with very limited hardware and created these crazy, awesome graphics.
Who's the roller coaster tycoon guy? Same scenario, but keep going with John Carmack.
And so it's just and now it's a joke, right? Now we run Doom on everything that has like a CPU, and like people are fighting to figure out how to get it running. I think one of the latest ones I saw was like people got it to run inside of, I think it was like the Gemini like prompt by adding a hook or something like that to it. I forget. But it was just crazy places people have gotten Doom to run. And like, that's because
you can run it on the Shaquille O'Neal pregnancy test.
Right.
Yeah.
And so it's just like, like these are legends because they were constrained. So
we wrote about this in our book, right? This is chapter 11 where we deploy a multimodal LLM and actually take a multimodal request on a Raspberry Pi.
Yep.
And I posted about this on LinkedIn a little while ago too. I've been seeing a lot of people talk about replacing their like $250 Claude subscription with Jetson Orin Nano. I don't like that, but not because I'm saying that you shouldn't experiment or you shouldn't do it. I don't like it because of the Jetson Orin Nano. I feel like if you're gonna be resource constrained, be resource constrained. You know what I mean?
Yeah,
Don't put an ARM GPU on there. Anyway, that's my hot take of the session.
No Jetson Orin Nanos.
You can't. Okay, yeah.
I'm just teasing. I
Yeah.
clearly I have 2 Sparks. I'm not the situation for that the resource need. I guess, but saying so, like we talked, I'm hearing a lot of like learning, like we want to learn how AI works, which I agree. I have been enlightened by your book, so I agree. I'm going to start plugging your book every 5 seconds, by the way, because I think it's amazing, and I'm so mad that I didn't read it 2 years ago now. But I think a lot of people have different ideas of what they want to learn with this. So like most people are like, okay, great. I just want to learn. I want to just run my agent. I want to just spin up my agent harness, and I don't want to pay for tokens. So I want to throw a model on there too and run my agent harness against a model. And I feel like that's more of how I see people using it. Does that need its own hardware? Does that something you can just throw on whatever you have around? What is the situation with that? Because like I feel
that's a big question. Because like
I do think that is a little bit of a bigger step.
Well, I think going back to what I said before, like if that is your main goal, start with something like RunPod. That's going to move you from paying per token to paying per compute.
Yeah.
And obviously then you
model.
can make the decision to okay, well, I like this user experience, and so then you can think about buying something like the Spark or something even bigger, depending on what model you want to run, just so that way. And then you're paying for electricity versus, so you're kind of making that movement from paying per token to compute to electricity.
And if you're not ready to like invest in it yet, even as much as RunPod is really cheap, but if you're not even ready for that, I mean, a lot of these harnesses like OpenCode ships with OpenCode Zen, and OpenCode Zen will often give free model access through their API or Open Router, right? So you can
Open
test.
Router has some free ones, yeah.
Yeah, you can test now. I have a harness. It's a local harness. Here's an open source model that I could run locally. How well does it do? Just like hit that, then go to RunPod for starting to measure your compute, starting to measure how much you actually have space for, and then we can talk about what hardware you might actually want, depending on your use case once you've decided.
Are there better hardware use cases for certain things versus other than?
I think so. Like for me, one of the biggest things is just IP, right? If you want to, and this is funny coming from me, but if you want to protect your ideas, you should be running it locally. And this applies to, right? This isn't just about intellectual property, but it's also about like highly regulated industries. If you need to make sure that something is absolutely correct, because you're working in law or healthcare or finance or one of these, or the military, right? Heavily regulated industries that have a lot of requirements, like, yeah, you need hardware. There's no way you're going to get by with like a frontier model fudging it a lot of the time.
I'm a hardware guy, like I like to look at hardware. And
I know, I have
over
the
things
wrong
that I'm never
people
gonna
getting
buy.
opinions from this for.
Oh, okay. Yeah.
Oops. You are, yeah.
So like there's a bias. We're like, oh yeah, like acquire your own hardware, own it. But there's also like a bias towards like owning my own data and just, having more control and not, owning my own attention and not necessarily giving it away freely. So I think there's your deeper question of, is there certain hardware better for other things? And yeah, I mean, like we've talked a lot about the Spark, and the reason why the Spark is so great is because, that 128 unified memory is just super flexible.
Yeah.
You can you can do inference, you can do training, you can do whatever you want. I don't think it necessarily does any of those things really well, but it does all of them, good enough.
Good enough. Yeah.
And so like if it's, it's a generalist, it's good. If you don't know your use case, it is $4,000 or $5,000 now to get started, but you can kind of do whatever you want, but there are definitely, hardware that are going to be more.
I mean, and you run into the thing, I guess I want to kind of expand that, right? We've touched on this slightly a little bit, but you get the dual purpose hardware. Oh, I want to learn about AI, so I'm going to buy a gaming machine that I could, also play games on, right? Or you have I need a new laptop because I haven't bought one in 7 years, so I'm going to look at one that I can also run AI on. Oh, look, they just announced the RTX new series, or they just announced the M5 for the Mac, right? So there, I think there is that question too, right? Okay, great. I do want to learn about AI, but I don't want to buy something just for AI. I want a dual purpose thing. So let's get a new laptop that I know I can do all the other things with I want to do and run AI. And I think that's an interesting thing too. It's like, what can you do on your laptop? On my 32 gigabyte M1, not as much as I can on my 64 gigabyte M5.
Right.
So it's like, but on an M5 with 60, you can do a decent GLM flash. You can run Claude Code against it. You can run a harness against it.
Yeah.
And it will seem snappy. You can do that on the RTX ones. You can get what are the, I don't know. I don't game, but I feel like 4080s are kind of like the highest people will actually see differences in their graphics on games. I don't know. People were saying like the 50 to go from 4080 to 5080, you didn't notice it in the graphics, but you do see it in the AI side of it, right?
I still use 3090s
for your graphics, yeah.
Yeah, for my graphics, and it's fit. The reason that I bring that up though is because I also use this computer is a little bit of a beast. It's got 128 gigs of DDR5 RAM and then two 3090s in it, and I use that for spot AI stuff. That's not an LLM server. Sometimes I will put a server up if I need something to go really fast and just solve a problem.
I don't know where I was going with that. I'm more just I guess I'm trying to say you get one of those dual purpose machines. What can you do? What are your limitations with investing in that, doing something as opposed to going full Homelab?
It's hard to say right now what the trade-off really is, because you can look at the AMD Strix Halo, right? This is the AMD version of the Spark or the Mac with the unified memory, and a lot of them have you can get up to 128 gigs of unified memory, so VRAM plus RAM, and they play games great, right? They're not going to be in the same class as if you get a 5090, because they're just not that fast. Unified memory is not as fast as an actual GPU accelerant. But it works awesome, right? If you get the framework desktop or you get the B-Link, I think it's the GR9 Pro or whatever the AMD Max Plus 395, that's the Strix Halo that I'm talking about. I've run Bazite on there. I've used it to play Black Myth Wukong. It's really good. So even with the unified memory, you are still getting a lot of the same dual purpose machine. The issue then comes into hardware support, which this is a big gripe that I have with AMD, that they're not supporting that Strix Halo. They just announced a new one.
Yeah.
And I fear that it will be the same amount of support as the previous one got, which is essentially just almost zero support unless you're running Windows. And then it's fully supported, but not really,
I don't like running Windows, so.
But you're not getting better with NVIDIA in that realm either, because the Spark is not going to be a gaming machine
at all.
You're not going to use it for dual purpose, even though maybe you could, maybe it may have been originally intended for something like that. You don't have it. And same with the Mac. As much as I know people love Macs, and as much of a good experience that I've had with my Macs, they're not gaming machines. No. You're not going to use them for that.
No, but it's just Mac.
Well, so I think my opinion on this is probably it's contrary to what people would expect, but it makes sense if you see what I've done. Is I would put more money into my main machine and go and buy a nicer gaming PC or whatever for like, this is my main machine. It's my day-to-day use. It's what I want, because I know when I'm done with it, it's going to go into my home lab, right? Like I'm not planning on selling it, right?
Yeah.
And so in my opinion, it's like I'm investing in it now for these purposes, and it's going to give me the capability, and it's the one I'm directly using the most. And so that makes more sense for me to kind of, instead of worrying about any latency by connecting to it remotely or anything like that. But then also knowing like when I upgrade, I'm going to move it into the home lab, and it's going to just be that much more power.
Well, this is what we were talking about before we even started recording, right? We used to kind of scoff at people that wanted to start learning machine learning, and they wanted to skip the math, and they wanted to skip the computer science, and they wanted to skip the programming, and they just wanted to jump into machine learning. And you're like, well, but it is all of those things, so you kind of have to have the foundation, right? We're seeing the exact same thing with LLMs, only they're skipping the machine learning and they're skipping the hardware. It's like, well, you kind of got to do it. So to translate what Matt's saying, like, start with a regular computer, make that computer a server, and then we can talk about like making it an LLM server, right? We can start there.
Honestly, this is why I've been telling everybody and their dog to read your book. Because it's like we 100%, I do see that problem. We want to start with the agent harness and prompting, and it's like, guys, you will spend 12 years arguing with your LLM, and I watch people do this and get nowhere because you're just fighting with a machine that has no cognitive
You're
function
with
at
a
all.
binary file.
Like, yeah, like at the end of the day, I think I really I think I personally, this is like I come at it with like great, I have all this great hardware at home. You're trying to do this on your Mac. I'm so sorry for you. You won't get anything done. And I think that is the wrong way for me to look at it, because how long did I run my Llama 3.1 on that 32 gigabyte machine, right? Like for $200. 2 years. And I got a lot of use out of it, right? You can get a lot done with whatever hardware you have around. You can run harnesses against it. Like, yeah, it's not going to be a snappy Opus, whatever. But
it can be. Right? It can't. That's what we're talking about here. It can be. But anyway, finish what you were saying. It's not going to be a snappy Opus, whatever. But
it will accomplish everything you need it to accomplish.
Yeah.
At the end of the day, like, what are you doing with your harness at home?
This is something that we've been talking about a lot in industry too, where I hear people a lot of the time talking about how state-of-the-art is Model Plus harness. And I agree with that to a large extent, especially like I posted about this a while ago. Forge is a guardrails local harness framework.
Yes, I've ripped it off and implemented it in Go.
Awesome. You should. Everyone should. Because Forge kind of demonstrates that when you have really good engineering principles around how you're designing your guardrails, around how you're designing your harness, it reduces the gap between the snappiness of an Opus, whatever, to your local models, right? They did it with Mistral, and it was an 8 billion parameter Mistral, and it was quantized down to 4-bit. And the difference across, I think it was something like 260 different tests, it was less than 1% between Opus and this model, and it was actually outperforming Haiku, and it was outperforming Sonnet.
We will have all of the links. It was I got the Y Combinator link, so like everywhere, because it is.
He spoke on it, right?
Yeah, but it's like there's a lot of documentation and evidence.
The point
around this.
I don't want to have you as viewers. I didn't want to lean on someone else's expertise for that, right? Because you can claim whatever you want. The benchmarks, the way that we're measuring benchmarks is not very reproducible, and that's why I think people are losing a lot of trust in them, because we're not talking about what harness did we use, what prompts did we use, what hyperparameters did we use, running it all in like a controlled way. We're just saying Opus got this on this. Right, we're not getting any of the details, so it's not reproducible. So I can't trust them.
No, we're not doing science.
You shouldn't trust those details that I'm saying either. Test it, figure it out, and that's why we want to tell you about the hardware that you can use to go figure it out.
Well, I was just having this conversation where people were wondering, how do you? They were, a student asking, how do you know which model to choose? And it's a very common question, and One response from another student was essentially, you know, the model doesn't matter anymore because the harness is 90% of what it is. So you know you can kind of plug in any model, and if you have a good harness, it's going to work. And I'm like, sort of, but like it really depends on the tier of model you pick.
Well, and it depends on if you know your task. Because like I can agree with that if you already know exactly what you're gonna do.
Well, it's also like, you know, the model might be only 10% of the overall system, but it's often 90% of the cost.
Yeah.
And that's either in tokens or generally like in Homelab scenarios, that's like RAM budget and like, you know, what you can fit into. And so oftentimes you are kind of starting, like if you're smart about it, you're still kind of choosing the model first. Maybe not like direct model, because so many of these models like in the same tier as in like a 30 billion parameter model, I could probably switch out with any other 30 billion parameter model, and it's not going to take up any change in RAM budget or things like that, but it's the same tier. And so, you know, like you're kind of starting at that level of like, what size of model do I want?
Yeah.
And kind of going from there. And, you know, this is going back to like the hardware constraints of like, you know, forcing yourself to run things on a Raspberry Pi in that hardware constrained area. Like it allows you to kind of, well, you're forced to pick different types of models. You're forced to kind of see where they go. You're forced to be more creative on the harness you have to create for it. You know, and ultimately, like you can, and what's surprising, what I think a lot of people miss is the surprising aspect is that little model on that Raspberry Pi with the right engineering around it can do the same things that, you know, Opus 4.8 can do, or at least for like one very specific task.
And a lot slower. Yeah.
Yeah, slower, you know, like if you specifically, you know, get the right hardware for it, you can make it. You can make it extremely fast because it's always going to be faster to run a smaller model than a bigger model. And so, like, you know, if yeah, I mean, if you took it off the Raspberry Pi after you got off that hardware constraint and put it on really fast hardware, nothing would be able to beat it in that.
Well, actually, I wanna hit on something you just said. It's always going to be faster to run a smaller model than a bigger model. That's not true. And I'm gonna get to why this is important though, because we are like kids in a candy shop right now at this moment. There's something that's changed in the last year. And this is from a problem that we've discussed before, that like we don't know how large of an intelligence a 30 billion parameter model can have. Those mid-tier models, it's kind of unbounded. We haven't fully tested out how good they can be. And we've hit 2 experiments in the last year that have been fantastic. That's Gemma 431B and Qwen 3.5, 3.6, 27B, where we get these dense models that are scoring above the 120B mixture of experts models. But Qwen 27B can fit in like 8-bit precision on my 32 gig laptop. Right? That's fantastic. We're hitting a point where like you have the literal power of the original ChatGPT, the 3.5 turbo. Probably I would venture to say even better than that. There can be some disagreements there, but like I would venture to say even better than that.
Tell us in the comments below how wrong Chris is.
Yeah.
Please rip him apart.
Do it. I need it. I would venture that far because we have tool calling and all of these other things that have progressed since then. However, right, like these models are like fantastic tier models that can fit on your devices. You need like 32 gigs of RAM.
I can fit all of 27B in VRAM.
Yeah.
And still do inference on it.
On a 5090.
On my 5090. Yeah. I do that, and it is slow because I have to tune it slightly. Like it will be fast. Like there's no reason it's going as slow as it is, but like it is, the whole thing's in memory, like in VRAM.
And this is where the hardware question is going to come full circle, right? Why are people so interested in the unified memory systems? It's because 5090s hit the meme. They cost $5,900 or $5,090. I keep doing that. $5,090. And they may have even gone up. RTX 6000 Pros, the Blackwells that are like fantastic, that are kind of the gold standard of if you're going to build one of these for actual production use that people are comparing against, those are like $13,000.
Yeah.
Compared to the Spark is like $4,500 at Micro Center right now.
Yeah.
Not sponsored. The AMD Strix Halo 128 gigs unified memory is like $3,000, $4,000 depending on where you get it from. The Mac, I don't think you can do it with the Studio, but like the Mac Minis that are 128 gigs are like $6,000, maybe 8,000, depending on if you're
That
getting
is the Mac Studio.
That is the Mac
That
Studio.
is the Mac
Oh,
Studio.
awesome! Yeah, like it's less, right? You get more budget to fit a bigger model, and you're just dealing with it being a little bit slower. But
It's a non-noticeable slowness for anybody who's not doing
right,
distributed inference or like
Yeah.
20 parallel requests.
well, that's why it's a question. That's why we're weighing these trade-offs right now, and the trade-offs haven't fully materialized for like what exactly they're going to be going forward, right? Because these markets haven't fully saturated with like what are people buying, what is the demand, what is the supply. All of that stuff is not fully fleshed out. But I can tell you from like what I've done, I have 2 Sparks, I have the Framework desktop, and I have a Mac Studio. They're all great, but I use them for different things because of these trade-offs, right? The Mac Studio is terrible at token prefill. That's one that I'm going to just set and leave. That's where if there's a task that I'm okay if it takes 2 days to actually run the full thing, yeah, I'll put it on there. And it'll use like over those 2 days, it'll use probably 500,000 tokens. It's not very fast at the prefill, which is important for agentic tasks, right? But it'll get it done because I can get a larger model on there and I can trust it a bit more. And I'm using the same harness for all 3 of these. That's one of the advantages of having an open harness. I think one of our commenters talked about that recently. Using open code for all 3 of these. The Spark, I have 2 of them clustered together, really similar to Miriah. I can fit a really nice model on there. It's a fantastic mid-tier model that is not even quantized, and like it runs pretty quick. We're getting 20 to 30 tokens per second.
Yep, that's about what I get.
The prefill is fantastic. It's like 1,700 tokens per second. It's multimodal. That's the one that you would use for like your day-to-day driving. And then the Framework is just like a backup, right? If you ever need something and both of the other 2 are tied up and you need it like pretty fast, but not too bad, like that's fantastic. If I were to start to try to support, let's say, a 5-person engineering team right now, I would probably go with 2 Sparks. That's going to run you a little bit under $10,000 for everything, but I can hit 190 concurrent requests if all those requests have like 0 tokens in them. At 100,000 tokens, we get down to about like 24, but like 24 concurrent requests that's enough for all 5 of your people to be running 4 different agents at the same time. If you're pretty good.
That was an information dump.
Yeah, it was huge.
If you're watching, go back.
Like just review that 3 times.
Okay, I want to get though. Like, do you have any gripes? Do you want to like nitpick what I was saying? Because that was an information dump.
No, I mean, everything you were saying was pretty right, but it was just like making sure that you kind of understand your specific hardware, understanding the pros and cons. Like, I mean, yeah, I mean the Spark with VLLM tends to be really good at taking a lot of concurrent requests.
It's amazing.
The Mac Studios, they're good. They're great. Good hardware, but yeah, they have that prefill problem.
They also run a full OS. You can't just Linux it and be like headless.
Yeah.
When will Apple give us a headless Mac?
That's unfortunately that's actually my only gripe with Apple computers is like you will always have the operating system as part of your memory.
This is going to be a tangent, but I think you're about to have more gripes with them. Have you seen the touchscreen stuff?
Yes, I've seen the leaks.
Cool.
I've seen the leaks. Yeah. Sorry, Matt. I interrupted you.
So I think, yeah, I mean, like every little hardware has a little bit difference. I think for a lot of users, understanding those details, you might not be there and it's not important for you to be there, and so, listening to this might give you better understanding. It really comes down to first though, like understanding your problem and then
so
getting at it.
We'll just wrap up real quick.
Sure.
Ease of use, right? So like say we don't have somebody that wants to go full Linux admin, whatever. but they want to host their own hardware. What would just be your really quick entry level, ease of use, get started? Obviously, Ollama, but like I don't care about Ollama. Just like
Sure.
yeah.
If you are familiar with Docker, I would probably say the AMD Strix Halo, because Qzo has fantastic repos for just a Docker setup for Llama CPP. If you are unfamiliar with Docker, if you're like that much more of ease of use, the Mac, right? Like, just install LM Studio on it.
No
LM
Windows
Studio,
machines
yeah.
with RTX support.
I do not. No.
Okay.
There's too many things to configure if you're going that route.
Oh,
When you said Docker, it reminded me that, yeah, like Docker desktop as well as like Podman desktop, if
Yeah.
you use that, like they have like these AI, I don't even necessarily know what they are called anymore, but like it's essentially like click of a button and you have both of them host them where you have the LLM running
Yep.
in, you know, a Docker container or
with VLLM,
Just a
you can do
container.
the same thing. Yeah.
yeah. And so it's,
If you already have a gaming PC and if you can do Docker, I think you're good.
Docker desktop runs on
Yeah.
Windows, runs
Yeah.
on Mac, runs on
Yeah. So that's a low aspect. I mean, you already said don't talk about Ollama. So
No, I'm not saying you can't talk about Ollama. I'm saying we already have covered that Ollama is the easiest one button. You have
Yeah.
a server.
it just is, because it doesn't matter if you have a GPU or
Yeah.
anything
Yeah, and it
else,
runs on
it's
like
just-
basically every piece of hardware. So it's like,
Yeah.
right? So I'm just saying, yeah, whatever. Essentially, like I think like the summary of this is just start with whatever you have,
Yeah.
and that is where you start. Like you don't have to buy a machine, you don't have to buy a Spark, you don't have to feel left out because you don't have a Spark. You have something that will run AI.
If you, for example, right, I have an AMD GPU laptop that runs Windows, unfortunately, but whatever. That laptop I use as an LLM server sometimes via Lemonade server, right? As much as I griped about AMD before, they do have Lemonade server on Windows, and it works with an AMD GPU or with the unified memory. It works, and it's really easy. It's one click, and then you have it, right?
Yeah, I mean, taking that a step back though, like if you're not happy with what you have, like maybe you have $1,000, like what would you buy? And then it really comes down to like, if you have like $3,000, I would just save your money until you have like $4,000 or $5,000, and you can go up to that kind of next
And just
year.
fight the FOMO. Just fight it so hard.
Yeah, I mean, like, and that goes back to my suggestions of making your hardware work for what it is, and realizing the pros and cons, and really doing your homework of what the next step should be, or using tools like RunPod or Modal where you're paying, you know, for the compute, which is, you know, dollars a week and not, you know, and you'll be able to save up to get to that.
Do you know what I wish that I could have said about that? I wish I could have said, just install Unsloth Studio on whatever you have.
Oh yeah,
It's not there yet. I want it to be so bad.
It's pretty close though.
It's good, right? It feels very similar to LM Studio, except you also have the ability to train.
And quantize and
Right. Yes, you have that. It's not quite there yet as like the simplest option.
this is
Yeah,
us
but-
starting the campaign to get somebody from Unsloth Studio on the podcast. I have tried to DM them so many times.
I mean, they're busy.
I know
Like,
they're busy, and it's like a team of like 8 people. It's so sad, but like biggest fans.
Yeah, dude.
Don't
Absolutely.
even. We'll talk it
Don't.
I'm not looking. Okay, we'll wrap up. We want you to thanks everybody for listening. We're on YouTube, we're on Apple Podcasts, we're on Spotify, we're on Patreon. We need you to comment and tell Chris how he's wrong. We do want to know what you're running. I've had a lot of enjoyment having people comment their stacks. We need you to comment more. We've also had enjoyment learning what meta harnesses were. That was from 3 podcasts ago. And yeah, what are you running, and what do you want to run? What is the next thing you want to buy? Yeah, anything else before we sign off?
Daniel Hahn, if you want to come on the podcast, let
Please.
us know.
Oh my gosh. Okay. And then we'll just who's going to count down for the keep your AI in a leash?
Let's just say it. Let's
Okay.
just go for it. Ready?
Right.
Keep
your AI on a
leash.
Oh my gosh, we did
I don't know what I said. I said all sorts of stuff.
Oh gosh.